Awarded to Costain Civil Engineering Limited and originally worth £9.5 million, the contract was to provide 4 deep-water berths for ocean-going vessels. Less than 2 years later, with expansion in trade boosted by offshore oil discoveries, the project was completely transformed. The builders now had a task of a very different magnitude, from a £9 million to a £24 million contract, from 4 to 15 deep-water berths. But although 2 years of work were already completed, the extensive design changes were put smoothly into effect. Now, an area of protected water of some 170 hectares, dredged to a minimum depth of 9 meters, had to be provided for. 2 breakwaters stretching out from the shore would capture this area of open sea, where previously 30 days a year were lost while lighters waited for calmer winds. The whole project to be finished by 1972. To build a harbour and breakwaters, you need rock. Big rocks, medium-sized and small rocks, each in its right proportion, and lots of them all together. With 2 breakwaters, each stretching 2.5 kilometers out to sea, separated by 3 kilometers of quay, you're going to need something like 4 million tons. And that was the first problem.
When you're driving outside the town of Dubai, you find the landscape pretty monotonous. The sand, sand, and more sand. But there's no sign of rock whatsoever. So the first problem was to try and find where in fact the rock lay.
Prior to the awarding of the harbour contract to Richard Costain, exploration was in the hands of the consulting engineers to Dubai, Sir William Halcrow and partners. At first it seemed that there was no rock to be found, until one day, during a conversation with the ruler,
he recalled an attempt to dig a well at a place called Bayadat, and there they had encountered hard material. They followed this up and put some borings down. This did in fact confirm that there was rock there, at which point we came to the picture and embarked on our own program of boreholes. This showed a great variance in the nature of the rock. You could put a borehole down in one place and another one about 250 foot away and come up with very different results.
Nevertheless, it was rock, usable and plenty of it. A trial face was opened and a quarry was bought. The quarry, though, was 30 kilometers inland from the town of Dubai, with nothing but sand dunes between. For exploratory trips, a Land Rover could make the journey unaided, but for lorries laden with 22 tons of rock, it was a different matter. So, before it could have a harbour, a new road was needed, and a new road was built. A road as vital to the success of the whole enterprise as any artery to the human body. The builders pitted themselves against 2 adversaries, the intractable desert and the hostile sun, and won. Before the harbour is built, the drivers would learn every twist and turn, every idiosyncrasy of surface and camber. For the 40 of these lorries will travel together over 11 million kilometres to feed the hungry Manitowoc crane as it creeps ever outwards above the surface of the sea. This is the final link in a chain of complex organisation taking rock from the bowels of the desert and delivering it into the sea. Man is changing the shape of Arabia for his own convenience and profit. It's here that statistics are forgotten and the immensity of the undertaking is felt.
You see the breakwater going further and further out to sea and begin to realize the scale of the thing. And it's always very difficult to visualize this correctly on paper. When you stand on the main breakwater and look out to where the lee breakwater is going to start, you realize what a long way it is. Just how far we've got to go before we complete the thing.
5 years in all before this restless energy stops and the designer's dream becomes reality. 5 years of work around the clock. The giant Manitowoc crane works 22 and a half out of every 24 hours, placing each trayload with ease, but with a necessary precision. The central core of the breakwater is made up of quarry-run rock of all shapes and sizes up to 2 tons in weight. Outside this is placed a layer of heavier armour stone, selected rock weighing between 2 and 5 tons. To the seaward side, in addition, are placed specially made concrete units known as stabits. The positioning of the stabits is of utmost importance. They must fit together in such a way beneath the water that no wave has direct access to the armour stone behind. As the full force of the waves breaks against them, the water must twist and turn as it seeks out the armour stone. In doing so, its energy is spent. Developed by Sir William Halcrow and partners, these ingenious shapes account for more than 1/8 of the total weight of material in the breakwater. 28,000 of them will be used, most of those weighing 15 tons each. For such quantities, production line methods were necessary. At the batching plant, stabits are manufactured in enormous quantities and stockpiled. The process begins by feeding concrete from a high-speed batcher into hydraulic side-tipping dumpers. Using an elevated road, the dumpers can feed the waiting steel molds. After a short curing period, the stabits, gleaming with a temporary aluminium-based curing agent, are moved on to the transfer point. The transfer point is the heart of the operation, where stabits meet the rock trays from the quarry to be stored or called for as progress demands. This is where the efficiency of the entire operation can be measured, where the margin between profit and loss is in balance. The Manitowoc crane mustn't wait. The train must keep it fed.
Yes, so in effect we have a chain. In the quarry there's the excavator, the truck hauling the rock, portal cranes offloading it, the rail wagons, and finally the Manitowoc. The whole of the cycle has to be balanced for maximum output, which requires a considerable amount of thought in order to iron out and prevent any hold-ups. Everything was going along very nicely when the contract was extended and the breakwaters lengthened. We still required to complete the job on time, and this meant an additional production of stabits. This was achieved by introducing additional moles to the system, doubling production by producing 2 stabits from each mole every day. Initial outputs of rock of 17,000 tons per week have now been increased to the order of 35,000 tons, with a record figure of almost 50,000 tons.
But while work steps up ever faster on the breakwaters, the quays themselves must be built. The originally planned 4 berths are sited parallel to the main breakwater, where the depth is already at or approaching the required 9 meters. To provide adequate quayside accommodation, a width of 180 meters is planned from the outer edge of the breakwater to the quay coping. Along this line must be driven piles to withstand the 20,000-ton weight of a laden ship. Over 3 kilometers of concrete will complete the quay walls and the transshipment berths.
Originally, the quay was designed as in-situ concrete on top of the pile. But due to the fact that some of this concrete is below water, it would have been a considerable problem pouring this in situ. So it was decided to go for a system of precast units instead.
"7,000 of these blocks in an assortment of shapes and sizes weighing up to 15 tons will be lowered into place along the quays. With them, 7,000 sheet piles and over 2,000 tubular steel piles must be driven home before the space behind can be filled. The 11-berth quay runs parallel to the shore, 270 meters out from the original coastline. Here, the natural depth of water is less than the required 9 meters. Dredging provides not only the necessary draft, but some of the sand required to fill in between the quays, the shore. A mountain of sand will be won back from the seabed and still fall short of the volume required for the total fill behind the quays. Much more must come from the land behind, but at least here is one material of which Dubia has no shortage. 13 million tons of sand and rock altogether, moved by machines, by men, by organization. You could dwarf 2 pyramids of Egypt with that. Of such are the modern wonders of the world. But that's not the end of it.
And then you start putting the concrete on top of the sand fill to form the area behind the quay. Because there's such a large area of concrete to be done, we're using a paving train, which is normally used on airports or road construction.
And why not, since the area to be paved is as large as any airport? A virgin coastline will become a concrete plain, and a permanent roadway will take the place of sandbanks and silt. For most of the year, daytime temperatures are so high that the concrete sets too rapidly, and so the paving train works only at night. Even then, the atmosphere can be oppressive and uncomfortable. massive transit sheds will stand on this ribbon of concrete. To build these is a formidable undertaking in itself, but essential in the light of Dubai's ever-expanding trade. With so much concrete to be made and so little rock to be found in Dubai, yet another headache.
There are problems in this because the aggregate we're using in Dubai is limestone, very absorbent. New techniques have got to be learnt in using an aggregate of this type. You can get perfectly good concrete from it, but you have to know how. You also have to learn how to live in the terrific heat and dust of the quarry. It's always several degrees hotter than at the harbour, and there's a constant bright glare, which is a bit troublesome too. Still, as far as I'm concerned, it's better than being jammed into a London tube train twice a day.
And the supply of cement in the quantities required threw up further problems. Problems which in themselves illustrate Dubai's pressing need for the new harbour.
The bulk cement comes all the way from Mombasa in East Africa. They use a bulk carrier of about 5,000 tons and transfer the cement to a floating packing plant a mile or so offshore. Trouble was, the packing plant could only get into the creek with 2,500 tons at the most. In other words, the carrier could only unload half its cargo. The solution was to erect silos on the east bank of the creek and fill them from the packing plant, which was towed back and forth. Then the cement is taken to the site by road.
And that's why Dubai needs its new harbour. Not just for cement or the heavy components of modern industry, but for watches, cameras, radios, furniture, shoes, clothes, canned food, cigarettes, toilet preparations, all the products, in fact, of 20th century commerce. The merchants who own and use these craft are canny businessmen. They know when to buy and where to sell almost anything, and at the right price. But always the margin of profit must suffer because of the time and money lost in carrying the goods from the big ships lying offshore. But not for much longer. They can look forward now to continuing profit from a faster, keener trade. The builders of Port Rashid, of course, take their profit only once. What endures is the experience won.
Well, every job is a little different from the others. The piling we did is pretty straightforward, but the use of stabits was comparatively new, and this involved a certain amount of underwater checking to make sure they were being placed in exactly the right positions. Concrete paving? Well, we soon learned how to pave with this type of aggregate in a very high temperature. It goes up to 50 degrees centigrade in the summer. Main problem in the quarry, of course, is dust. It's not a difficult rock to excavate in that it is very soft, but it certainly kicks up a lot of dust. And that means that maintenance is that much harder. Plant has got to be maintained very carefully, all the filters checked daily, that sort of thing. But all this was foreseen and taken care of. We have a very efficient and well-equipped maintenance shop, and so far we haven't had any serious hold-ups at all. I think this is where experience counts. After all, we're Britain's largest overseas contractor. We've been operating in all sorts of climates and conditions for quite a long time now, and frankly, I don't think there can be any hazards or difficulties left that we couldn't cope with.
For Ahmed, it is the end of another day. In the desert, the distant sound of the pile hammer is borne softly on the evening air, testifying that at the harbour at least, day and night are as one, offering to Ahmed and all his countrymen a symbol of a future that their fathers could scarcely have imagined. And so it was that on November the 19th, 1970, the arrival of the first passenger liner in the now half-completed harbour heralded the handing over of the first two berths 1 year ahead of schedule. A day to remember for the people of Dubai and for the constructors of Port Rashid. From this moment, although perhaps few realized it at the time, life took on a new dimension for the people of Dubai. They had always been an enterprising and industrious people. In the past, these qualities had been hamstrung by an accident of geography. From now on, it would be up to them